Hey Jess, let's take a look at these two. Sorry for the late response. Pretty hard for me to do these at home. I like having kind of the full functionality of the computer at work. Anyway, first one, let's solve the given system of equations. We have a system here, all the x's are lined up, y's and z's, so let's throw that into a matrix. And our matrix is going to be 5, 2, 4, 2, negative 3, negative 4, negative 5, 2, that's a 5, that's a 2, 4, and then we'll do an augmented line, that's our equal sign, negative 2, 19, and 36. Okay, so that's our augmented matrix. And now let's just do a whole bunch of row operations on this guy. I'm gonna take this whole, now again, we might go to fraction town on this, right? But I think we're gonna go to fraction town pretty badly. Let's do this. Let's swap these two rows, just saying, and then I'm gonna quarter that row. I'm going to divide each of that row by 4. Okay? Because we can do that, remember? So let's do that. That first row, 4 divided by 4 is going to be 1. Then we're going to have negative 1. Then we're going to have 1. And then 36 divided by 4, augment line is 9. And I'll just rewrite row 2 is the same. 2, negative 3, what's that, a 2, ugly 2, 19. And then my last row, remember, I'm going to swap that down here. So that's going to be 5, 2, negative 5, negative 2. Okay, now you don't have to do that. I'm just trying to avoid or maybe prolong going to fraction town. That's fine. I just want a 1 here. Now we want zeros below that 1. So basically I'm going to take this 1, I'm going to multiply it by negative 2 and then add it to this row because negative 2 plus 2 gives me 0. So if I want to write that out, it would be negative row 1 added, negative 2 row 1 added to row 2. That's what we're doing here. So let's do that operation. Row 1 is unchanged, 1 and 9 with an augment line. Row 3 is unchanged as well. It's only the last row that we're kind of notating here that changes, by the way, so you can just copy the other ones over. Keeps the mind clutter down. Now negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 1 is positive 2, plus negative 3 is negative 1. And then that's going to be negative 2 plus 2 gives us a 0 there. And then negative 2 times 9 is negative 18 plus 19 gives us a 1 right there. Okay? Beautiful. And now we'll do the same thing. I'm going to take negative 5 row 1 and I'm going to add that to row 3. Okay? Because again, that would be negative 5 plus 5 gives me a 0 there. So let's do that. I'll copy over the other two rows. They're unchanged. Feel free to skip ahead because this is like watching paint dry. And if I make a mistake, we got to start all over. So that's awesome too. Okay, but basically negative 5 times that added to 5. I'll show you what I'm doing. Let me zoom out one here. Yeah, there we go. Okay, so negative 5 times that is negative 5, plus 5 is 0. Negative 5 times negative 1 is 5. 5 plus 2 is 7. That's going to be negative 5 plus negative 5 is negative 10. And then that's going to be negative 45 plus minus 2 is minus 47. Okay, watch your negatives on all that. So that's cool. We got zeros there. Now this row, I want this to be a 1. So we're basically just going to multiply this whole row too. We could just write minus R2. So that's going to be a plus 1. I'm just going to erase that because I need room badly. That's going to be a minus 1 basically. Just multiply every element here by negative 1. Then we want to get a 0 here. So I'm going to take negative 7 row 2. Negative 7 row 2, and I'm going to add that to row 3. Okay? And that's going to give us, again, I'll just copy the first two rows. Can't be lazy. You gotta copy them out. I tried to erase as I go and stuff. It's like, you can't do it. You got to just bite the bullet and give her. Just write her out. Just kill 2 pages on one question. Okay? We still have a 0 here. That doesn't matter. So now, negative 7 times 1 is negative 7. Added to 7 gives us our 0. Negative 7 times 0 added to 10 is still just negative 10. And then that's going to be 7 plus negative 47 gives us negative 40 right there. Okay? So now at this point, let me just erase a bunch of stuff here, buddy, because I'm dead on room. I thought a page is enough. It's not enough. Nowhere near. Okay, so here's what we have, and I'll change color to indicate that we're still working on this, but we'll do something else. Basically now, let's take this now, and I want this whole mess, I want that to be a 1. So if I divide that by negative 10, that'll be 1, right? Because negative 10 divided by negative 10 equals 1. That's what I want to do there. So in matrix notation, I would basically say I'm going to multiply row 3 by negative 1 over 10. And that's just the same as dividing, right? 1 times R3 is R3 over 10. It's just by convention, we always write it as like a multiplying type of thing. So basically, let's just divide both these by negative 10. Okay, that's going to be 1, and that's going to be 4. So just to save a little room here, I am going to erase those right there. Okay, so that's going to be 1 and 4. And now we basically kind of solved this, Jess. I know that these are all my x's. I know these are all my y's. I know these are all my z's. But I know a solution as well. I know that 1z equals 4. So that's cool. We know that. I'm going to write that down so I don't forget it. Z equals 4. I also know that y equals negative 1. Right? Y equals negative 1, because there's no x and no z here. If there was a z, I could just write this out as a little equation and solve it using algebra. And then this one, I know that x minus y plus z equals 9. Right there, that's our top one. So 1x minus 1y plus 1z equals 9. And I know what z and y are, so let's go ahead and just rock this one out. Negative 1 is plus 1, plus 4 equals 9. Combine some like terms here. We got x plus 5 equals 9. I'm going to subtract 5 now, just doing algebra. X equals 4. Okay, so as an ordered triple, remember we always want x comma y comma z. It's going to be, I'll write that out, x comma y comma z as a, as an ordered triple. So our answer is going to be 4 comma negative 1 comma 4. Make sure you always put those in the right order too, buddy, because you could do all this work and just switch two things and you get it wrong, and it's super frustrating. Okay, so I hope that helps. Let me know if you have any questions about that one. Let's take a look at the second question you asked. Now we have to find the function f of x equals ax cubed plus bx squared plus cx plus d for these values here. So f of 3, negative 3 is 96, f of negative 1 is 2, etc., etc., etc. So remember, we're using function notation here. So that's f of x, which means this negative 3 is our x. So if we just took this right here, this first one, we're going to make an equation out of that using this form. Okay, so instead of this, I'll just write like the general, instead of this, ax cubed plus bx squared plus cx plus d, instead of that, let's blast in what we know. F of x, or f of negative 3 in this case, is negative 96, so we'll put that in for our solution. Now, I don't know what a is, but I know what x is. X is negative 3, so that's negative 3 cubed plus b times negative 3 squared plus c times negative 3 plus d. No idea what that is. And we'll just take this a little bit further. Negative 96. Now negative 3 cubed is going to be negative 27. So we'll just write that as negative 27a. Right? By convention we put the coefficient or the number first. Over here that's going to be 9, two negatives, right? So plus 9b minus 3c, because that's a negative, plus d. So there's our first equation right there. So this is a system of equation. We're going to have 4 different equations. I'm going to rinse and repeat this now for this other one. F of negative 1 equals negative 2. Okay, so using the same format here, negative 2 is my solution, and I know that x is negative 1. So this is going to be a times negative 1 cubed plus b times negative 1 squared plus c times negative 1. Hopefully you get like the picture here, right? We're just blasting all these in. Negative 1 cubed, that's going to be like negative 1a, right? Negative 3 negatives there comes out to be negative 1. Negative 1 times a is just negative a. Don't write the 1, you'll get made fun of. Plus b, that's going to be a positive, minus c, that's going to be a negative, plus d. So there's our second equation. Okay? Go through that and rinse and repeat, and you're going to get 2 more equations as well. Here's our other one, right? So 4 is going to equal, and then you do that, the 1 is x. And then here, 19 is going to equal, and the 2 is x. So you just go through that, and now you're going to get 4 equations. And honestly, for the test, you're not going to need to do a 4x4 matrix. We have 4 variables and 4 equations. That is, quite frankly, insane. So here's what you do, honestly. Look, you just go to Google, matrix solver. Hit the first one, that's cool, that's a good one. And then you just blast it in. Our dimensions here, we're going to do a 4 by 4 matrix, just like this. We're going to set your matrix. You put all your numbers in there, just take those 4 equations, put them in. B is your answer, by the way. And basically you can fill all your empty cells with 0 if you want, and then just hit solve, and it'll blast out the answers. If you want a very detailed solution, it'll work it out for you as well. But honestly, just do the old solver. Okay? Give that a try, buddy. Let me know. Keep up the great work.